Hi, I'm Shyamala, working as Assistant Professor in Nalla Narasimha Reddy Education Society's group of institutions. In this video, I'm going to discuss about the Cayley-Hamilton theorem. First, I discuss the Cayley-Hamilton theorem statement. Statement of Cayley-Hamilton theorem is every square matrix satisfies its own characteristic equation. What does that mean? That means, suppose if some matrix A has characteristic equation lambda cube plus 2 lambda square plus 21 lambda minus 45 equal to 0, then A satisfies this equation. So the statement is telling that every square matrix satisfies its own characteristic equation. So if we have our matrix characteristic equation as this one, then A satisfies this equation. That means if we substitute A in place of lambda, then what we have to get is, in place of lambda cube we will get A cube, in place of 2 lambda square 2A square, in place of minus 21 lambda minus 21A minus 45 into I equal to O. Here it is the null matrix, and here we should not write just constant because these are all the matrices. We have to write constant into identity matrix. So a Cayley-Hamilton theorem states that if a square matrix, every square matrix satisfies its own characteristic equation. So whenever it is having some characteristic equation, in place of lambda if we substitute A, we have to get the null matrix. That is the Cayley-Hamilton theorem statement. Applications of Cayley-Hamilton theorem are to find the inverse of a matrix, we can use this Cayley-Hamilton theorem, and to find the higher powers of the matrix also we can use Cayley-Hamilton theorem. Now in this video I am going to discuss about the verification of Cayley-Hamilton theorem for a particular matrix, and also hence find the A inverse and A power 4. So first, we have to have the characteristic equation first. That is why consider the characteristic equation determinant of A minus lambda I equal to 0. As we have already discussed that the modifications will be in place of diagonal and remaining all elements remain the same. So the diagonal elements are 1 minus lambda, 1 minus lambda and 2 minus lambda. Now we have to find the determinant. 1 minus lambda into multiplication of these two, 1 minus lambda into 2 minus lambda, minus multiplication of these two, minus 1 into 1 is minus 1. Next, minus 1 will become as plus 1 for the second element, into 0 into this 2 minus lambda is 0, minus 2 1 ja 2, that is what I have written here, plus third element is 0, so we will write 0 here. Now we will simplify 1 minus lambda into multiplication of 1 minus lambda into 2 minus lambda, constant will be 2, then minus 2 lambda minus lambda will give a minus 3 lambda, and plus lambda square minus 1 we have, then minus 2 equal to 0. Then 1 minus lambda into lambda square minus 3 lambda, 2 minus 1 plus 1 minus 2 equal to 0. Then multiply these two elements. Then 1 into these three elements will give us the same. Minus lambda into these three gives us plus 3 lambda square minus lambda cube minus lambda minus 2 equal to 0. Next, so if we write them in order, minus lambda cube first, then 4 lambda square minus 4 lambda minus 1 equal to 0. Or if we multiply it with minus 1, we get lambda cube minus 4 lambda square plus 4 lambda plus 1 equal to 0. Now we have to verify Cayley-Hamilton theorem. That means if we substitute A in place of lambda in this equation, then we have to get the null matrix. That is nothing but the verification of Cayley-Hamilton theorem. So we have to show that A cube minus 4A square plus 4A plus 1 into identity matrix, that is I, equal to O. This we have to show. So to verify that, we have to take only the left hand side and we should show that is equal to 0. But to go for that, first we need a square and a cube. That is why we will find a square and a cube first. I will show you how to find a square and then a cube you need to do on your own. Now, a square means A into A, given matrix A into A. Now, how do we multiply these two matrices? First row into first column, first row, second column, first row, third column. Gives us the first row elements. So, let us see that how we have done. 1 into 1 is 1. Minus 1 into 0. That is what we have written. 0 into 2. 0. Next, first row, second column, 1 into minus 1, here we have written, minus 1 into 1, here we have written, 0 into 1, 0. Next, first row, third column, 1 into 0, here we have written. Next, minus 1 into minus 1, next 0 into 2, that gives us the first row. Now second row with first column, second row, second column, second row, third column. So 0 into 1, 1 into 0, 1 into 2, 0 into minus 1, 1, 1, 1 into 1. Next 0 into 0, 1 into 1, 1 into 2. Like that, third row, first column, 2, 1, 2 into 1, 1 into 0, 2 into 2. Let us observe it in this row. Next, 2 into minus 1, this row I am talking about. Next, 1 into 1 and then 2 into 1. Next, 2 into 0, I am talking about this element now. This element, 2 into 0, 1 into 1, 2 into 2. So if we simplify all those things, we get this matrix. In the similar way, we have to find out a cube. A cube means a square into a we can multiply, or a into a square also you can multiply. Then we will get that a cube matrix. Now we should consider only the left hand side, which I showed you in the previous page. Only left hand side we consider, and then let us write all those matrices. A cube minus 4a square plus 4a plus identity matrix I. Now what we have to do is we have to add or subtract or multiply whatever we have here, all that we have to do with the corresponding element. Suppose if we are taking the first element, then go for the first element in this matrix and then go for the first element in this matrix and then first element in this matrix. So minus 1, minus 4 1 ja minus 4, next 4 1 ja 4, next plus 1 plus 1. Okay, like that. Now if we go for second element, here minus 4 you have, so that is what I have written. Minus 4 into minus 2 plus 8, then 4 into minus 1 minus 4, and here you have 0, that is why I have not written anything. Now coming to the third element, minus 4 in that I have written here, then minus 4 into minus 1 plus 4. Here we have 4 into 0, 0, and here anyway it is 0. So we have this one. First row is completed. Now coming to the second row. Here 8, here minus 8. Okay, that is what I have written, and the other two elements are zeros. Next 3. Next this is minus 8. Next this is plus 4, and this plus 1. Next 8 minus 12 plus 4, 0. Next 16 minus 24 plus 8, and then this is 0. So that is what this one. Next 0 minus 4 plus 4, that's what I have written here. Next 16 minus 20, sorry 11 minus 20 plus 8 plus 1. So simplification of all these elements will give us simply the null matrix. So that is called the verification of Cayley-Hamilton theorem. Hence the theorem is verified. Now to find A inverse, again we have to go back to this equation. This one. We always consider this one to find A inverse and also to find A power 4. Okay. So to find A inverse, we consider this one. To find A inverse, what we have to do is we multiply this equation on both sides with A inverse. Then we get A inverse A cube minus 4 A inverse A square plus 4 A inverse A plus A inverse into I equal to O. Next, A inverse into A cube is A square. A inverse into A square A inverse into A is I plus A inverse into I is A inverse equal to O, and we know that A inverse into A is the identity matrix I. Now let us write only A inverse on left hand side, remaining all elements on the other side. Then we have this minus A square plus 4A minus 4I. Now let us write A square, then 4 into A plus minus 4 into the identity matrix. Simplification of all these three matrices. See, first minus 1, here plus 4, here minus 4. Next plus 2, and here minus 4, and then 0. Like that we have to see all the elements simplification. Then we get this matrix. This is the way of finding A inverse using Cayley-Hamilton theorem. Now to find A power 4, again we consider that equation only which we considered for A inverse. So this is the equation which we consider. To find A power 4, we multiply by A on both sides. Then we get A into A cube, 4A into A square plus 4A into A plus A into I equal to 0. So A into A cube is A power 4 minus 4A cube plus 4A square plus A equal to 0. We need A power 4, that is why write it on left hand side, remaining all on the right hand side. And we know what is A cube, A square and A. Substitute here, and then if we simplify all these, then we get this is minus 4 and this is also minus 4, this is minus 1. Like that, this is minus 16, this is plus 8 and that is plus 1. Like that, minus 16 plus 4 and 0. Like that we have to write for all the other 6 elements also. Then we get A power 4 like this. So this is a way of finding A inverse A power 4 and verification of Cayley-Hamilton theorem. Thank you for listening my video.